Good evening all. Welcome to tonight's TI webinar hosted by Texas Instruments Australia. We are really excited to bring you further mathematics, recursion and financial modelling with Brian Lannon and Sanjeev Meston. My name is John Beaumont and I am your host for this event. I teach mathematics to years 7 to 12 students at O'Loughlin Catholic College in Darwin, where I use TI technology to help students and make stronger connections in their understanding of mathematics. Tonight, I'm excited to introduce our first panelist for the evening, Mr. Brian Lannon. Good evening, Brian.
Good evening, John, and good evening, listeners.
As you can see, Brian is a very experienced teacher of mathematics and physics in a range of educational establishments. He is an equally talented TI national trainer, and I always learn something from Brian when he runs a workshop or webinar. So good luck tonight, Brian. I'm looking forward to hearing what you've got to say.
Terrific. Thanks, John.
Our second panelist for the evening is Mr. Sanjeev Meston. Like Brian, Sanjeev has many years' experience teaching both mathematics and science, but on an international level. He is head of mathematics at Lakeside College, as well as having the enviable role of STEM resource developer.
Thank you. So just making sure everyone is in the right room on the right day, here is the overview of this evening's webinar, to which we've titled Recursion and Financial Modelling. Now, just a quick trip down memory lane. Almost a year to the day, Sanjeev and I ran a webinar of the same topic, and it went busy on the internet. I don't want to say viral, because that sounds like a disease, but let's just say it was very popular. It was the highest attended webinar live, and also got the most hits on our YouTube channel and download afterwards. So,
now, Brian, you can't count all those just because it's your mum. You know you can't count that.
As I've been saying, everyone, please follow this link, and they just click on it, and then they're in. Yes. So we're aware that some people tonight may have already seen the presentation last year, in which case we're wary that we don't want to rehash the same material too much, hence a live poll question that we will send out asking you, first of all, did you attend that webinar? And that may appear on your screen at some time. So a yes, no, maybe. So did you attend it, or did you watch the recording? And then if so, do you want me to rehash the recursion components? Because I remember I spent a bit of time on that, and have also done so in face-to-face workshops, and you see that live poll coming up now. Actually, that's a different question that I'm seeing there, John.
Yeah, no, I was so excited about sending out a live poll for you.
Excited.
That,
he's preempted me on something else. I will actually jump forward in my PowerPoint to address what John's just sent out, and then I'll come back. What John just sent out was an invitation to you. John and I have both been involved this year in taking over the hosting role for the webinar program, and that's been a pretty interesting and enjoyable experience. One of the things we're aiming to do is trying to make the live webinars more interactive, and as part of that, we're going to, an idea we've come up with is to invite you, the teachers, to become webinar presenters in a guest spot. So why a guest spot? I mean just a 5 to 10 minute guest segment incorporated into next semester's webinar program, so not this semester but next. And it doesn't have to be necessarily related to the current topic of that webinar. It's just, around the schools, what's happening? What's a clever technology-driven lesson idea that you'd like to share? Why do we want to do this? To get sharing happening. You can see the polling thing there. If you're interested, it's non-commitment at this stage, so just an expression of interest. Tick yes if this is something that you can see yourself being interested in. We would then contact you via email and just ask a little bit about your lesson idea. And then if you decide to give it a go, we'll negotiate with you that guest spot and also give you some training on how the WebEx system works. Some of you may have used that for other school PD as it is. And you would then get a certificate of acknowledgement of not just a PD participant, but a leader of teacher training, which I think is a good thing to do. It is possible, of course, that you are watching this as a recording after the event, that is after the 2nd of May, in which case, if you're watching a recording, then you've missed the opportunity for the live poll, obviously, but if you email me, that's my email address there, then we will get back to you to explore that idea with you. We're hoping that at the very least we make, through doing this, we make the webinars more interactive, and possibly even, I can't promise this, but I do know that Texas Instruments, through the T-Cubed, that is Teachers Teaching with Technology program, are often on the lookout for more innovative teachers to develop as their trainers. John, Sanjeev and myself are all certified T-Cubed trainers and attend a lot of conferences and receive training and technology as part of that. So that's just another possibility. Okay, how are we going on that poll, by the way, John? Is there much interest?
Well, I was that excited and got carried away setting it out, then I panicked and closed it down again.
Hit the wrong one. Oh, you closed it. You made me address all that out of turn. Okay.
Well, it was,
so,
and I'm just openly now just setting that straight back out. So do not worry.
Okay. Last year I spent a fair bit on the recursion component of this topic. Would you like me to address it again? Basically, yes or no. What we would like to predominantly address here is the financial modelling component in the study, that's core of the study design, investments, loans, depreciation, and simple compound interest, nominal and effective interest rates, and annuities and perpetuities, amortization tables.
Brian, your screen looks like it's frozen. All we're seeing is the first bullet point that you've got.
I'm seeing it is on my other one. I'm seeing that is fairly slow. I'm just going to stop sharing and reshare again.
Just to let you know that on the poll so far, so would you like Brian to quickly give an overview? 48%, just over 50% have replied, and 11 said yes please, or 48% said yes please, and 9% said no, we're okay. But obviously those are the ones that already watched your video, maybe.
Okay, well I might do that just briefly then. Yep.
There we go. Can see your screen now.
Okay.
Right. Okay.
So coming back to my screen, those key points from the financial modelling part, and the screen share is looking fairly dodgy. I'm going to cut from, okay,
there
now
we go.
We've got it.
I can see it now.
Yep. So there's a bit of a lag.
I think you're trying to put people off actually wanting to do a presentation yourself, so you should have
yeah, that's right.
just stayed with it from the start and showing them how easy it is.
If you too would like the joy of working with this software, just call us. Okay. No, there's a bit of a lag there. I'm blaming it on the NBN, John. I don't know about you, but there's a bit of a lag there. I will simply read what I've got on my slides. For the overview this evening, review key concepts of recursion only if you wish. We mainly then want to look at some exam-style questions, explore some of the finance features on the CAS calculator, a demo of the financial solver, consider ideas and sources of ideas for SAC tasks, and also look at some lesson packages that can be downloaded from Senior Curriculum Inspirations. So I'm going to stop sharing, and Sanjeev will take the bulk of that and swap back to me to close the show out. Hopefully Sanjeev's screen will share a bit better than mine.
Well, hopefully he's been paying his internet bill and we should be okay. There you go. See, I told you he would have done. I told you he would have it all sorted.
Can we hear you though, Sanjeev?
Sanjeev, can you hear us? See, he's been paying his internet and not his phone. You've been paying your phone.
Okay.
Sanjeev?
Hello. Hello.
How are you?
Yeah. I lost
your cord,
the
mate.
audio. Yeah.
Yep.
Is the audio back? Can you hear me now?
We can hear you just fine,
And
and we
we've
can
got
see your screen. That'd be
share.
fantastic.
Tell us
Okay.
the story.
All right. Okay. My screens are very self-explanatory, so I won't go through everything on the screen. But I'll just highlight the terms that I would like to focus on. So that's basically an explanation of linear recursion. So linear recursion can be expressed as a relation, and obviously the value of the new term depends on the previous term. And then I've got some examples there. So that's just a quick explanation of what linear recursion is. And obviously we can model any arithmetic or geometric sequence with linear recursion. Now the TI-Nspire does the recursion beautifully, and as Brian mentioned, if you go through last year's webinar, it goes through all the basics of recursion on the TI screen. So we'll skip some of those. So I'll now move on to my next screen, and you have a challenge question there. It says write a recursion relation for the sequence of the terms 1, 4, 9, 16, 25. And they're pretty much square numbers. So if you were to write an explicit relation, that's over here. That whatever number term you're looking for is simply n squared. Now that's the explicit rule. But as a recursion relation, we end up with a rule like this. So the ninth term, for instance, would be n plus 1, which would be there. So what we've got is really a recursion relation. So T8 plus 2 times 8 plus 1. So we've got those, and we get that as 81. So the arithmetic is shown over there. That's a recursion relation. Whereas right underneath that, there or here, we call that as an explicit rule. Moving on to the next screen, the recursion model for linear growth or decay. If it is growth, we obviously have plus, and if it is decay, it's going to be negative. And that just tells us what D is. So you may be given a rate of interest, and you go over 100 because we've given that as a percentage times the initial term, and we just follow that recursion pattern. Now, I would like you to try this on your calculator screen, because normally if I do a recursion, so let's say, I'll just move this to the other side, the code. So if I do 5,000 and I click enter, now if I do a operation over here, let's say if I do plus, by default you will see what displays in front of the plus sign is answer. So it picks up the last answer, and basically that's going to be used for recursion. So I don't have to type that, it comes up automatically. If I put a multiplication or addition symbol, it comes up. And now I can go plus 25, and I click enter, and you can see it now. It just follows the recursion pattern. But in this, the drawback is, if I want the 10th term or the 11th term, I have to keep counting, the number of times I click the enter key. So to overcome that, here is a solution. So if you look at this screen here, if you type this on your calculator screen, in curly brackets. Now, what it will do is it will generate a list. So it will have two answers as the output. And this time, if you see what I've got for step 2, it says answer with a square bracket. So that will pick up 0. And then answer 2 with a square bracket. So 2 is within the square bracket. That will pick up the second answer there, or the second term, 5,000. And now if I click enter, it will actually generate a recursion pattern in this manner. So what I've done over here is I've entered 0 and 5,000, and then all I've done is this. I've entered this, and I'll actually demonstrate that by going to my test screen here. So 0 and 5,000, enter. And now you see I've got answer 1 plus 1. So what it will do is it will add 1 to the 0, and it will, my answer 2 was 5,000, to that it is going to add 2250. So if I click enter, you see the output is 1 and 7250, and the recursion pattern continues. So now it's telling me that's term 6 for me. So I don't have to keep counting when I'm doing the recursion. So this is a smarter way of doing the recursion on the calculator by using answer 1 or answer 2. And that's what I have done over there. Okay. I've got some examples there now, and following exactly the same thing. So a car valued at 6,200 depreciates at 15%, determine its value at the end of 5 years. There's a question, and we are using this recursion relation. So first I calculate the value of D, which is 15% times my original value over 100, and D turns out to be 9,600. So in my recursion relation, I've got 0 and 64,000. That becomes my answer 1, 0, and 64,000 is my answer 2, and I'm deducting that value 9,600 at each stage. And what it generates is this over here. So after 5 terms, the value of the car will be 16,000. So I won't go through that, but all I have done is use this syntax over there. Answer 1 and answer 2. I can have 3 terms, I can have 4 terms, and subsequent example is going to actually display that. I hope I'm not going too fast.
No, I think everyone's staying with you very well there, Sanjeev. And
All right. Yeah.
it's, and with that big screen, when you've got the screen set as a computer view, it's amazing how much you can see, isn't it, on that screen?
Yeah. Now, I've got the same example, but this time it's depreciation. So I've done answer 2 minus 1,200, and you can see it keeps deducting 1,200. But this is an example of unit cost depreciation. So if you read through the example, it says it depreciates at the rate of $1,200 for every 5,000 kilometers. So I started with 0 case. Now I want to add 5,000 to that. So 0, 5,000, 10,000. So I'm adding the kilometers on one side, and I'm subtracting the depreciation value on the other side. So each time 12,000 is separated. So it's giving me the value. So after 25,000 kilometers, if you follow my cursor there, the value of the car is 58,000. And then after 35,000, it's 55,600. So basically a simple recursion done on the calculator screen. While I'm actually mentioning that, I'll just click here. What you're seeing is the same file as a published view. And the good thing about this is the same information is there. I have got this as a PDF. So at the conclusion of the webinar, or in a couple of days, you will have access to all these files that I've got. So you will see it in a PDF form as well. So I printed this as a PDF. So whatever I'm talking about is all here. So we just talked about this example. It's all here. And it's probably a better view.
And Sanjeev, it's obviously on demand as well. So not only can they get the resources to use to review themselves or use with their students, but they can actually go through the webinar again. Sometimes you need a couple of times learning anything new on this and the technology as well.
Yeah. So if you see, like, this is a better view. So exactly what I just said, and everything is displayed there probably more clearly. Okay, I'll go back to my screen there. And basically, general rule instead of recurrence. Now, if you are teaching VCE classes, although the topic is called recursion and financial modeling, but if you read the study design, it clearly says we can use the explicit rule wherever we want. So you can actually use the explicit rule as well. So there's no restriction on you using that. But if you follow the recursion pattern, basically that's what we are doing. So recurrence can be used for investments and loans. It could be a growth or a decay, flat rate depreciation, unit cost depreciation. And now we are moving on to the geometric aspect, the geometric sequence. And over here, instead of adding constant term, we multiply it by R. Okay. So R can be determined using this formula. So it's 1 plus R over 100. And in this case, the value of R is going to be greater than 1. So for growth, R will be greater than 1. And for decay, the value of R would lie between 0 and 1. So that's what I'm mentioning. So 1 minus for decay and 1 plus for growth. So we've got another example there. An investment of 60,000 earns compounding interest at 4.2% per annum. It says, write a recurrence relation to model the value of the investment. That should be off. So I can change it right here. Okay. And that's the recurrence relation there. And the value of R is 1.042. So I've gone 1 plus the rate of interest over 100. And that's a live calculation. So if I say evaluate, actions evaluate, I can get an exact value there or an approximated value. So I'm getting 1.042, and now that's my recursion relation. Now, these questions that I've taken are from the sample VCE exam. I've seen some figures and the nature of questions, and also later on I've got the actual 2016 exam questions. On the calculator screen though, you would enter these values and then once again answer 1. That's 1. Now instead of adding this time, you would go times, so 1.042 times answer 2, and you hit enter and it just keeps generating this sequence. So we've got it down there. So you can see actually it's getting compounded now. And I've just checked the answer by using the actual rule, which would be 1.042, that's the rate of interest to the power of 5 times my original value, and I get 73,703.8, and that's the value here. If I was looking for the fifth one, so we do have an option to use the explicit formula. So that's showing recursion on the calculator screen. Now you will see in this particular example, I've used actually 3 terms, so 0, 0, and 50,000. It says determine the final amount and compound interest earned on a principal sum of 50,000. So that's the principal sum deposited for 7 years at 6% per annum compounded annually. So output 1 is the year. Output 2 is the interest earned after first year, second year, and so on. So that's going to be the interest earned after each year. And then output 3, so output 3 is going to be the amount after each year. And if I enter this, which would be displayed in the next screen, I've got these terms, it will generate a recursive pattern, and I'll end up with this value. So after 7 terms, that's the interest and that's the value there. So let's look at that, and that's exactly what we've done there. So we started with that, then I've done answer 1, answer 2, answer 3, and it keeps generating the information that I want. So once again, probably if I go back to this one, you will see it probably looks better here. That's the one there. So you are actually getting 3 outputs this time. And we're looking at this one. So for the 5th one, we get these outputs there. Then we've got reducing balance loans. Now I won't go through every single example. If you just have a quick look, so I've got answer 1 plus 1, answer 2 plus whatever the rate of interest. Now obviously I've divided by 12 because it is compounded monthly. And $800 is paid back, so I've got that as the value of D. So this is a reducing balance recursion relation. And once again, if you go through the recursion cycle, after 3 years, that is 36 months, so we'll be looking at the 36th term, you should end up with this value. So basically what you're entering on your calculator screen after you've entered your initial values is just that. and it generates the whole recursion pattern. Okay, so enough of that bit. Once again, we got some questions from the VCAS sample exam. If you want to have a look. And then I've done the same thing on the subsequent screen here. And you can see it's quite a long thing. So I've got 1, 2, 3, 4, 5 terms over here. So answer 1, then answer 2, answer 3, 4. Each one of them is being, a mathematical calculation goes, and it makes sense, when you kind of break it up for each one of them. And then as a result, we obtain actually 5 outputs. Now you can see that. So you can have any number of terms in your list here. Okay. The same question can be done using the list and spreadsheet method, and obviously it's more readable in this case. So that's the number of payment, so the payment number, and that's the value we are paying in. That's the interest being calculated on that amount. Now, at the bottom of the screen, you'll see what's the calculation being done now. I'll click here in a moment, and you'll see actually it's basically set up like Excel. So 50 is the interest you would pay on 10,000 at the interest rate we've got, which I'll just show, and the 450 will go towards reducing the balance. So if I click here, now you'll see the formula there. This is all based on cell reference. So that's why I'm starting at the principal value, which is E1. So that's cell E and 1, so E1. And I'm going 1 plus, so now I know from here the rate of interest is 6% compounded monthly. And then I'm saying minus E1. So it gives me that, and if I click here, that's just saying it's B2. So you go to this value minus this, and it should give you that result over there. And this one here, again, is a calculation. You're saying this value minus D2 over here will give you this. So it's like Excel now. It's basically being filled. So I just want to show you, once you have written the formula, if you go under action, in data, you have an option to fill. You click and you just move your cursor down, and it will start filling all your results. And likewise, this one over here, you will see it is doing a cell reference. So as you would do in an Excel spreadsheet, that's what we have done over here in the list and spreadsheet application of the TI-Nspire. And then if you want to graph this, now this looks like a straight line, but actually it's not a straight line. It's a curve. So if you look at the value, it's the same data that I've graphed. So it's actually a curve. And then this one down here, it's again a curve, and this is the interest at each stage. So we started with 50 and then 47.75 and so on. It's the interest that we are paying on the reducing balance. And I want you to have a look at this. You can use I feel this is probably the quickest and the best method to display our information. So we use the amortization table. Now, I've got over here, this is the information that the table requires. Now, in your calculator, I'll go here. If you go under finance, and you will see option of amortization table. If you click that, and it shows now what really needs to go in there is this bit of information. So the first bit that you put over there is the number of payments. So I've got that as 25. I'll show you that. So I want 25 payments. The actual number of payments for the entire loan period, I put 30. It should be 60 or whatever, if it is spread over 6 years or whatever, or 5 years. The rate of interest, the principal value, that's the starting value or the present value. Then monthly repayment. Now, monthly repayment, I put a negative sign. So that's something that you just need to be careful with, a negative sign. The future value in most cases would be 0. And then that's the number of payments per year, and that's compound number of times you're paying, that's the compounded yearly or monthly, whatever. So in our case, because it's compounded monthly, I've got 12 and 12. Generally, PPY and CPY values would always be the same. So all I do is enter that information there. So I've got 25, 36, that's my starting amount, and so on. And then it generates this. Now, if you look at the table, it gives you basically 4 outputs. That one is, these two together, if you add them, should add up to 500. I've got a negative there and a negative, and it deducts that amount from 10,000. It deducts 450. So my next balance is 9,550. So I'm going to be paying the interest on 9,550, and the interest calculated is 47.75, and that would mean it offsets my balance by 452 again, and you can see it generates each term, and somewhere around there after 21 my balance would be 0, because you can see now it runs into negative. So it will take me about 21 point something payments for me to completely pay off this loan based on the information that I have provided.
Sanjeev, we just had a question come in. Somebody asked, could you repeat what are the F outputs again, please?
Okay, I'll go back there. So the outputs over here. Are we talking about this one?
I would think it would
yeah,
be.
the four F outputs, yeah. The 4 columns.
Yeah, okay.
Can you just repeat those?
So that's the interest you're paying. So the first column obviously is telling you the payment number. So payment after first payment, second payment. So the first column is after, the number of payments. So if I click on number 3 there, that's telling me after 3 payments. Then if I go to column 2, that's the total amount I was paying each month was 500. Now that 500 gets divided between column 2 and column 3. Now, of the 500 I paid, $50 went towards the interest, and 450 is offsetting the amount. So I started with 10,000. So it offsets 450, and that leaves me with a balance of 9,550. So the last column is giving us the running balance. So now if 9,550 is the balance after the first payment, the interest I'm paying is on 9,550, and the interest I'm paying at 6% comes to 47.75. And as such, 452.25 is the amount being offset. So the total of column 2 and column 3 would always be 500. So if I take any of these, column 2 and column 3 will always add up to 500. That's the amount I'm paying. So column 2 is the interest on my balance amount, and column 3 is the offset amount over there. Does that clarify?
Great. That's fantastic. Okay. Yeah, thank you very much. The other question was, what is the advantage of using this over using the finance solver on the Nspire?
This actually generates all the terms, whereas finance solver only gives you the final answer. It does not show you all these terms, So the table shows you, So, with the finance solver, if I put after 20, it will only give me this over here. It won't show anything before that or after that. That's it.
Yeah.
So
I would agree that it shows the steps along the way, and it makes it much more clear what's going on than just the magic of the solver. Also, some of the exam-style questions that we've been getting actually have amortization tables in them. So for students to understand how those tables work.
Yeah. So now, since you asked that, that's a finance solver, and if you look at it, I will only get one output. So it says I will be paying off the whole loan after 21.124 terms, but it only gives you one output as such. So you don't see what happened in between.
So it's a bit like seeing your statements, isn't it? I know you can change it to be fortnightly or monthly, but it's like seeing your 6 monthly statements coming in and just demoralising you along the way.
Yeah. Actually, that's a good
this
analogy.
Is the output of the finance solver, the same question done on the finance solver. Okay, cool. I think I'll probably take another 5 minutes, Brian. Is that okay?
Yep.
All right. Now, this screen over here has got the 2016 exam 2 questions. Now, some of the questions are very straightforward. If you have the exam in front of you, you'll see it's asking us what is the rate of interest and so on. So that's pretty straightforward. It says write a general rule. So it didn't ask for a recursion relation, but it did ask for a general rule. So which is that, and we've already been through that one there. And then it says, hence determine the money in the savings account after 10 years. So in this case, I've used the general rule, and it gives me the output. Then that's the next question there. So I'll just take up, so that's again exam question. So the purchase price for the caravan was 38,000, and after 8 years, its value is 16,000. So it's depreciated. So what's the average depreciation per year? It's going to be the initial value minus the current value over 8 years, and the negative sign basically tells us it's depreciation. So the depreciation is $2,750 per year. Then you have to write a recursion relation, and then final question was the caravan travels an average of 5,000 kilometers per year for 8 years while it was in use. What is the unit cost depreciation? So that's the depreciation over the number of kilometers being done. So it basically comes to 0.55. So that's all calculator based and pretty straightforward. That was the other question there. So this is the information that we had. So I don't have the whole question. I just got the information that we need. So the amount borrowed is 70,000. Now I'm using the finance solver over here. So that's the present value. Rate of interest 6.5. It's compounded monthly. So I put the number of payments as 12. And the monthly payment that you're making each time is 800. So repayments of 800. Now that's the negative value that I put over there. And we are looking at the future value. And basically it gives us the future value as 65076. And you could use that as negative and payment as positive. Both ways you'll end up with the same answer. So you could use either of the options. So the question was, how much of the repayments would have gone towards the interest? So what you're paying is 800 per month into 12 months. So you have paid that amount, and then you take this difference, and that will tell you the interest. So if you have the question in front of you, it would probably make more sense. And then another question from the exam. I won't go through every single thing because you likely have access to these files. So I've got a screen capture of what we are doing. So in this case, you enter the information on the finance solver. The only field that you will leave empty is the future value because that's what we are determining. And you put your cursor in the future value field and you click enter, and it should generate the answer that we are looking at. So the balance of the loan after 3 years would be that. And then if you're looking at the present value, we have solved that. So all these questions are basically from 2016 exam. This is a question on annuity. So I won't actually touch this question because I think Brian is touching on annuity and perpetuity, so I'll skip that. So this is exam 1, the multiple choice. You have 8 questions, and once again, half the questions in multiple choice can be done without calculator. It's straightforward and simple logic. Just reading the question actually has the answer on most instances. So I'll skip those questions. I just want to see if there's anything that you want to look at in particular. So this is a question on annuity and perpetuity. This was in exam 1. This is all exam 1 questions. I think the only question that I'll actually go to is the very last question, and a lot of students got this wrong. And I have shown why they got it wrong. So that's question number 24. Where it says investment in an annuity earns an interest at the rate of 5.2% per annum compounded monthly. If the balance after 5 years is this and the balance after 10 years is this, what is the monthly payment received? Now, most people, and I've done that, made this error. They kept the present value and the future value, because those are the two bits we are entering, as positive. And if you keep both of them as positive, you will end up with an answer of 3,460. And that was an option listed in the multiple choice. And a lot of people went with that option, and which was incorrect. So what we have to do is to have the present value, the starting value is negative, and the future value as positive. And then that tells us what is the monthly payment, which is 1,500. So I've got a note over there. A common error was to choose option E, which was 3,460 or 640, whatever it was, which corresponded to both the present value and the future value being incorrectly allocated the same sign. So they actually should have different signs. So present value should go as negative and future value should go as positive. So I'll stop there, and Brian probably would be anyway talking more about it. Yeah.
Yep, let's
That's
do
great,
it.
Sanjeev. Now, Sanjeev, I noticed quite a few of your questions that you done in the notes page with a maths box. Was that just for the presentation tonight, or would you encourage students to do it like that?
I use actually both calculator and notes. The good part is you can keep making changes. It's a live calculation, but the only drawback with the notes is obviously, even if you insert a math box, you cannot use recursion on the notes page. The recursion can only be done on the calculator page. Yeah. So I prefer doing other calculations on the notes page, because I can write comments, I can put extra information, whereas on the calculator page, I have to insert it as a comment. And the notes page, you can have a lot of color. Yeah. All right.
Because it creates beautiful documents, and so that's why people would have been asking, no doubt. It's a resource that I think a lot of teachers aren't aware of. They tend to think, hey, it's a calculator, and just use it for calculations, rather than being aware that they can actually produce very good, high-quality lesson package documents for their students. Particularly,
and now they can just take them off Sanjeev, off the resources when it goes out to the on-demand. Yeah. You save a lot of time. There you go. Thanks, Sanjeev, for everyone else.
Fine, thank you.
All yours, Brian.
So, gentlemen, I'm going to go very quickly here, because looking at the remaining time, participants, be aware that as part of the follow-up package, you do get a copy of all of Sanjeev's PowerPoints and the associated calculator files there, and you get a copy of my PowerPoint here. I'm not going to have time to address it all due to our little technical hitches at the start, but I will move quickly through an overview of it. Most people in the live poll said yes, they did want to see the recursion, so I'll very, very briefly address that. I won't do as much on the exam-style questions, but I'll show you what is contained here, so you can then review it at your leisure. We have only about 12 minutes remaining. So last year, Sanjeev and I focused particularly on the recursion component of this topic, recursion and financial modelling. And we looked at, this is from the study design, we looked at, actually that's the finance ones that I'm highlighting there, with the aid of technology. That's what we've done now. On recursion, we looked particularly at the first order linear recurrence relation. Look, it's said there 1, 2, 3, 4, 5, 6 times, and also again algebraically. So it's something that we kind of need to know what that means, first order linear recurrence. Well, what on earth is this first order thing? Well, I'll give you a quick explanation. If you understand second order from a familiar sequence, the Fibonacci sequence, that is in fact a second order difference equation, because you know that the next term anywhere in the sequence is determined by looking at the 2 previous terms. And this is from a package on Fibonacci. So if I said that the initial term, T0, is 1 and T1 is also 1, then the nth term will be Tn minus 1 plus Tn minus 2. So I'm going 2 back in history to define my nth term. Just on that point, you'll see that in our study design, it's actually not the nth term that's defined, but the n plus 1th term defined in terms of the nth term. That's the way that our curriculum writers have said it's going to be presented in the exams. So although it's basically the same way of explaining different way of explaining the same thing, the nth term given the n minus 1th term, or the n plus 1th term given the nth term. Basically, it means the next term along. And a couple of ways we can do that here. Repeated operations on the calculator to illustrate patterns. Sanjeev has already demonstrated that. And for example, I could input the value 5 and put plus 3. Every time I press enter, it comes up with answer plus 3. Or I could, so that's what we would previously called an arithmetic progression. This one here, what we previously called a geometric progression. The previous answer is being multiplied by 2. This is the linear idea. Remember, it's first order linear recurrence. So what's happening is I've got some geometric component multiplying by 2, and then an arithmetic component adding 3. So that's what we mean by first order linear recurrence. And in each case we need to have an initial term, and then we develop the current term by looking back once in history. And that's kind of replacing the old arithmetic and geometric progressions that we've had in the past. You could do the same in a spreadsheet, whether you do this on a calculator or using Excel. Or you can, on the calculator, use what's called the generate sequence command. And there's a new feature here too. I was talking to a teacher just last week from my boyhood homeschool, and she was discussing this too, that there is a way to do it, setting it up to be whether it's the nth term or the n plus 1th term. In a spreadsheet, if you go to Data, Generate Sequence, then you can set up the formula like this. The U bracket n means the nth term. You see here it's being defined in terms of its previous term. The nth term equals the n minus 1th term plus 1 more. And I'm going to count 10 times there. So what that will do is just add up a sequence of numbers counting by 1. That's what that does. Here's another way of doing the same thing, and it's being done on a graphs page. I've done a split screen here to show the graph and also the table. So here you see term number 1 is 1, term number 2 is 2, term number 3 is 3. This is counting by 1s. And can you see the difference? I've got the n plus 1th term equals the nth term plus 1. See how that's different to what's going on over here? If you're wondering with this U1, what that's indicating is that it's the first, the number 1 simply refers to that this is the first sequence that has been defined in this particular problem. I could go back and hit Tab, where it will open up the entry line, and if I wish to type in another sequence, it would be called U2. Okay? To access that, any graphing page, when I go to entry, it shouldn't be on the window. Zoom, graph entry, sequence, and select sequence here. I don't know why that went to window zoom. So that's a new feature there, and that's in operating system 4.2. Update to that if you don't have that one. Exam questions I will look at ever so briefly. Recursion and financial modelling. This is from the VCAA sample paper number 1. Here we have the initial term, and here we have the subsequent term n plus 1 being defined as, can you see the linear bit here? It's like saying mx plus c, where our gradient or our rate of change is 1.5. We can do that the way Sanjeev has already shown us. We could do it the way I just mentioned with the sequence command, and we could do it also with the graphing sequence command. So depends on which way you want to skin your cat. You've got 3 different options. Similar sort of thing here. Well, this is really testing the understanding of geometric decay. So option C there. I think all 3 of these are option C. Here we have one that's looking at this business of effective interest versus nominal interest. So we have somebody who's investing $1,200 for a year, and there's an effective interest rate, a nominal interest rate of 6.75% per annum, but we're compounding daily. So what's the effective interest rate on that? What's the difference between the 2 things for a start? Well, here's how I see it. I'll remove this other stuff. First of all, the students have this formula in their formula page. This is part of the exam paper. So we get this big, cumbersome-looking formula. Personally, I'm not a big fan of it. I'm not a big fan of the divide by hundreds and multiply by 100s. I did see Sanjeev, you're doing that too, and there's arguments both ways. I am teaching also in an engineering diploma. Anything percentage-wise we look at, whether it be an efficiency rate or proof stress, we just simply look at decimal numbers and consider the percentages from that. If I read 0.05, well, that's 5%.
So, Brian, isn't 100% 1?
It would be in that argument, yes. So 100% is 1. What's happening here is it's a plug-and-play formula where students would take that 6.75 and replace it in here for R.
Yeah.
They can do that because the sign says percent. So 6.75%, of course, is 0.0675 as a decimal number. You are quite correct there, John. Of course, what I would do is run it through, and I'm aware that this is a magic black box as well, but I would run our $1,200 through the financial solver. Sanjeev talked about the different direction of money, so I'm saying it's negative $1,200 when I have to give it to the bank. It's positive when the bank gives it back to me, and I've set up the payments per fortnight and also the compounding terms as 365. Now you see how much money I get at the end. It's $1,283 and approximately 79 cents. If I take the difference from the original invested and then divide by what I invested, here I've got this decimal figure. So I'm going to go for 6.98%, option D for this one. Alternatively, I could have taken the formula from the student formula sheet and I could have plugged into that, which I've done here. So be aware that your students, of course, will think differently. They would like to approach it differently. I recommend that you show both ways and try to then determine which better suits for which particular students. They will probably tell you. What isn't on the formula sheet, however, is how to get nominal interest rate from the effective interest rate. I've just written that formula in and done a solve, and it's spattered around the other way. You can see I've got R effective, R nominal. The textbooks will show this second formula, and there's an example. I've taken the 6.98 and run it back through to return the 6.775. The reason for the slight difference is because I initially rounded over here my 79 cents, remember. John, we're getting very close to time. I'll run through the PowerPoint slides, but this one's on the amortization table. I think all the correct answers here are C. And just an explanation of those, how each of these columns are developed, and it's the It's column B on the calculator amortisation table that Sanjeev demonstrated. It's the same numbers in the same order with the exception of column B. Column B is not included because basically it's just a fixed one, as you see. So that might be a useful page. Use this with your students if you can see some value in doing so. In the development of SAC tasks, which I'm sure you're likely to be looking at the moment, VCAA questions, the sample papers there are a good source. Of course, we've only got 1 year of past papers. Can I recommend you also look into state? I've recently been looking at and involved with a program in Western Australia. If you just simply Google WACE, they've got some great questions, as also does SACE. So look for both of those. You can look to commercially produced papers. Some of them you will find online for free or shell out the money and buy some. Other schools, of course, and again online you can often find schools will put their SAC tasks up there or talk to other teachers from other schools. Our Maths Association or other maths associations are very helpful, and just generally hunting through Google to find some good questions. Here are some also that I can share with you. These were developed by Australian Math Software. I won't go through them now, but you've got them in the PowerPoint. Again, an amortisation table there. If you seek more ideas, and again this could be used in SAC tasks, on the Senior Curriculum Inspired website and also the Australian Curriculum Inspired website at TI, you've obviously found your way there to enrol in a webinar. This is one of the activities that I wrote and published for it. For each task you will get a PDF document for the students, a PDF document for teacher notes, which includes the answers, and you also get the TI-Nspire document. So three documents for every task. Here's another one on modelling compound interest using recursion, and here are some others, AFL dominance, etc. So for each task, there are those three documents.
And there's plenty of resources, like you said, Brian, on that website, isn't there? There's so many resources.
It's absolutely packed and getting better all the time. Yeah. Remember, if you just simply go to the Texas Instruments website, you might end up in Texas. So may I suggest that you type Texas Instruments Australia, and you'll get to the Australian site here. Plenty more online. I've given you some links here. Also our YouTube channel, and a reminder, that invitation, we did get a few people in there, which is great to see. And if you missed the live poll and you're still interested in just doing a 5 to 10 minute guest spot in one of our later webinars, please email me. There's my email address at the bottom of the page there. So John, that was a quick overview at the end.
Fantastic.
But I'll hand that back to you.
Thank you very
John?
much. Yes, hi
John. Yeah, just a quick one. In the chat, I've actually put a direct conversion that the CAS has for effective to nominal and nominal to effective. Actually, there's a built-in syntax under finance. It's called interest conversion. So you can go either way. All you need to do is to type the nominal rate and, whether it's compounded yearly or monthly or whatever, and it actually converts it. So I'll just put the syntax here directly. So under chat, you'll see the last two. Yeah.
Yeah, so if people click on the chat window, which they should have there, or even click above and bring it down, that would be great. Well, there you go. So, wow. Plenty there for us to take away, and some lovely feedback from some of the people that are watching tonight, so thank you for that. It's very important. Thank you very much to Brian and Sanjeev for a very informative webinar, and also producing those resources that we can then access once it goes up onto the TI Australia website. So thank you, gentlemen. We are going to begin to wrap things up now, so if you have any last-minute questions, please try and get those answered, as I know Brian and Sanjeev will endeavour to answer them, and they will also add those to planning of future webinars. And as you saw, Brian's email address, murray.math, isn't it, Brian?
Yes, .math, it's just M-A-T-H.
Yeah, math, sorry, like the Americans.
Yep, that's big point, yep.
As we know, tonight when you leave the webinar, there will be a brief survey which will automatically appear in your browser. Your feedback does guide us as we plan future online events. We will listen to your feedback. So we hope you will share your thoughts in a post-webinar survey. And like I said, thank you to the teachers who've done so already. Your certificate of attendance will be emailed to you in the next 48 hours. And as like Brian said, along with a link to the on-demand and YouTube version of this recording, as well as any relevant documents. And I think those are gold by both Brian and Sanjeev to support not only your learning but also to support your students in the classroom. If you do need any post-webinar follow-up, feel free to phone or email us. We'd love to hear from you. And sadly, that brings us to the end of tonight's webinar. Thank you very much, Brian and Sanjeev, for everything you've shared tonight. Really appreciate it.
Thank you, John.
Thanks, John.
My pleasure.
Thanks, Sanjeev.
And likewise to all of you out there who've joined in tonight for the hour, thanks very much for joining us. And we hope to see you back online again soon. So good evening all and good night.
Good night.
Good night all.